Hey guys, in this video, we are going to try to convert a quadratic function from standard form into factored form. So there's two kind of methods for this, and they're also known as factor by grouping and also the AC method. I'll explain what the AC means here in just a bit. So hey, here's a function, f of x equals 3x squared plus 6x minus 9. So this is a quadratic function in standard form, and we are going to convert this into factored form. Why would we do that? It's because factored form is awesome for finding solutions to quadratic functions, which we're going to do eventually. So that being said, let's go ahead and try this problem out. For factor by grouping, show you what this kind of means. We'll start with the AC method. So in standard form, you know that the first coefficient is known as A, the second coefficient is known as B, and the constant off to the end, the y-intercept, is known as C. So the AC method, it's organized like this. I like to make an X, and on the top of this little diagram, we'll go A times C. On the bottom will be the coefficient B, and then the left and right hand sides are your factors. So let's just try the problem, and I think it'll make this make a lot more sense. So I'll set up a new diagram, a new AC diagram like this. All right, so my top value, what I'm going to put here is 3 times negative 9. 3 times negative 9. So hey, 3 times negative 9, that's going to give me 27, negative 27 rather. This bottom term is just the value of B, which in this case is a positive 6. All right, so this is where things get a little bit tricky. We need factors, say factor 2 there. We need factors that multiply to give us negative 27, and when added together, give us positive 6. So it really is kind of a trial and error. Let's think about what we can multiply to give us negative 27. So negative 27 is equal to, I could do negative 27 times 1. So the issue there is, if I do negative 27 plus 1, I don't get positive 6. So we can think of some other factors. Another way to do this would have been negative 27 could be positive 27 times negative 1. So again, if I do 27 minus 1, I get 26, not just 6, which is what I'm looking for. So if I try another set of factors, like maybe if I were to do 9, or let me actually write negative 27 first. If I do 9 times negative 3, I get negative 27. And also with this, 9 minus 3 combined to make positive 6. So hey, these are the factors that we're looking for, 9 and negative 3. 9 and negative 3. So I'll put a 9 here and a negative 3 there. 9 times negative 3 is negative 27. 9 minus 3 is 6. And this is honestly probably the hardest part about this process. So going back to our function that was in standard form, we're going to rewrite this now. We're not changing the value of anything. We're just expanding it. So f of x is now equal to 3x squared plus 9x minus 3x minus 9. Okay, so you see how I can still get back to this original equation very easily. 9x minus 3x gives us 6x. All right, so this factor by grouping, so we did like the AC method essentially right here. Now we need to factor this by grouping. So grouping just refers to group up the first two terms like this, and then I'll put another line over here to group my second two terms. All right, now we need to pull out of this. We need to pull out of each group the greatest common factor. We are looking for the GCF of each group, So what is the largest term that goes into both 3x squared and 9x? What is something I can take out of both of these? Essentially, what can I divide by and like not have a remainder? So the largest value that goes into both 3 and 9 is a 3. And each term also has at least one x. This doesn't have an x squared, so the largest x I can pull out is just x to the power of 1, or just, x. So I'll go 3x. Now in parentheses, what is left? So what you put here is like, what can I multiply to get back to where I started? So 3x times something gives me 3x squared. The answer to that is just x. Okay? 3x times x gives you 3x squared. Plus 3x times 3 would give you 9x. Fantastic. All right, moving on to the second group. We've got negative 3x and negative 9. So in this group, the greatest common factor is only going to be a number because the 9 here does not have an x next to it. So I'm not going to be able to pull out a variable. Notice that they both have negative signs, so I do want to pull that out as well. So the greatest common factor between 3 and 9, the largest number that goes into both 3 and 9 is 3. And again, I'm pulling out the negative sign. And then in parentheses, I can write this out as x plus 3. All right, we are almost done here. So moving on. Notice that 3x is getting multiplied by x plus 3. Negative 3 is getting multiplied by x plus 3. So one easy way to check your work at this point, these two groups have to be the same exact thing. They have to be exactly the same in order for factor by grouping to work. So anyhow, maybe I'll write it out like this. 3x, I'm just going to rewrite this kind of expression here. So 3x is getting multiplied by x plus 3. And then, hey, what else is being multiplied by x plus 3? Well, that's this negative 3 right here. So I can write this out as 3x minus 3. All right. Hey, so that is converting to factored form. That's really it. Now, if you want to, you can multiply these binomials, work your way back, and get to this original equation. This is not going to be mandatory at this point, but one more thing you can do to make this a little bit easier to read is you see in this first group I have 3, and then I have a negative 3. So I can actually factor out of this. I can rewrite this function as 3 times x minus 1. That'll just make finding solutions later on down the road a little bit easier for you. All right, maybe we can try one more factor by grouping problem. Let's go like this. Example number 2, yeah? Work through one more with you in this video and then we'll call it a day. So example number 2. Let's convert this function to standard form, or from standard form to factored form. So f of x equals, make this one a lot easier for you, x squared minus 7x plus 10. So we can use the same exact method for this as well. We are going to go like this, set up this little chart. Now the number on top is the value of a times the value of c. This times that. So it's just understood that there's a 1 here. So I'm doing 1 times 10 to give me 10. On the bottom goes the value of b, which is negative 7. And then these are the factors that I need to find. So factors of 10, maybe I'll write it out and it might help. I need factors of 10 that add up to negative 7. What can I multiply to get 10? But add up to negative 7. So here, 10 can be equal to 10 times 1. 10 times 1 equals 10. But if I combine these, they don't add up to negative 7. Alternatively, remember that a negative times a negative equals a positive. So negative 10 times negative 1, that would also give me positive 10. But hey, if I combine these, I'm not getting negative 7. So I'd have to try something else. 10 is also equal to 5 times 2. So hey, that looks like it's just about going to work, right? 5 times 2 gives us 10, but 5 plus 2 is positive 7. So there's something you could do to these values to make the expression work here. And that would just be 10 is equal to negative 5 times negative 2. If I combine negative 5 and negative 2, I'm getting negative 7. And if I multiply these, of course, I'm getting positive 10. So let's go ahead and list those as our factors, negative 5 and negative 2. Okay, when you find these factors, it really just comes down to rewriting your expression here, this part of your function. So I'll rewrite this as f of x equals x squared. So what we're doing is expanding this middle term using these factors. X squared minus 5x minus 2x plus 10. All right. Now comes the factor by grouping part. I'll group up these first two terms. I'll group up these second two terms. All right. Now, when you get to these groups, what's the greatest common factor? What is the largest thing that goes into both x squared and negative 5x? We're not going to be able to pull out an actual number, but we can pull out an x from each term. So it'll look like this. F of x equals x times x minus 5. X times x minus 5. Now we'll move on to the second group. The largest thing that goes into both negative 2 and positive 10 is going to be negative 2. Which leaves me with x minus 5. And hey, that's the reason I pulled out the negative 2. Remember, I want these two groups to be the same. After factoring, I want this to be exactly equal to this. And then I can just rewrite these because I know that both x and negative 2, right, my x and my negative 2 are both being multiplied by x minus 5. And that's it. There's nothing else to factor out. That is absolutely all this function would become. Fantastic. Hey, so I'll have another video with some more examples coming up soon. Otherwise, thank you guys for watching. I'll see you in class. Bye-bye.